This is 3.1 day 1. We're starting a new chapter and it's about mainly exponential functions, but we'll get into some others along the way as well. But today we're going to start with exponentials and talk about some of the basics. So one thing that we need to know about exponential functions is their basic form is y equals a times b to the x. So here's what those different parts are. First of all, a and b are going to be real numbers. If they're not, then this isn't an exponential function. And a is not equal to 0. If this were a 0, then we wouldn't even have anything. It would just be y equals 0, and this equation would not be worth looking at. B has to be a positive. If b is a negative, if you plug in a negative number for b somehow, then you're going to notice a really interesting graph that kind of fluctuates back and forth between positives and negatives, and so that will be really strange. You can try it if you want to, put it in your graphing calculator and see what happens. It'll be fairly interesting. But with exponentials, it's got to be positive in here. B is the base, also sometimes called the common ratio. That's what we're going to be multiplying by on each integer step. A is the initial value. That is, well, it's also a couple of things. It's the y-intercept, and it's also where x equals 0. And so on pretty much any function that we could ever think of, we plug in 0, we're going to have the y-intercept, and that's the same thing here. It's just that the number a out in front is going to serve as that. Now, when you're looking at your table, what you're going to be looking for are a couple of different things. A from the table is going to be associated with where we have x equal to 0. So from each of these, you'll notice we've got 4 and 8. That's going to serve as our a in this case. And the amount that we multiply by each time is going to be our b. That's our common ratio. And we'll take a look at writing the equations for those. So here's the same table. Just now we've got the functions ready to go. Let's start with g of x. As I mentioned, when we look at 0, we are finding the y value that's associated with 0. So the initial value for g of x is going to be 4. The initial value for h of x in this case is going to be 8. The ratio is just how much you multiply to get from one to the next. Now notice in my table that I'm going from -2 to -1. -1 to 0, 0 to 1, and so on. The x values are going up by integer values and by 1 each time. And so it needs to be in that format if you're going to use the table to find your ratio. So in this case, we're multiplying by 3 each time. So our ratio on g of x is 3. And in the case of h of x, it's going down, but really it's multiplying by 1/4 each time. So think about it in terms of multiplication rather than division. So if we've got now our ratio and our initial value for each one, we just plug it into our form y equals a times b to the x. And so for g of x, it's just going to be 4 times 3 to the x. And for h of x, it's going to be 8 times 1/4 to the x. Now I mention this every time we talk about this example. It is really, really tempting to want to multiply those two numbers together. So a lot of people will say that that's 12 to the x, or they say that this one's 2 to the x. But you really want to avoid that here, because remember that with the order of operations, exponents always come first. So if we're taking a look at this one here, whatever that happens to be for some number to the x, we have to deal with the exponent first. Once we deal with that, then we can multiply by the initial value, but only after we deal with the exponent. So don't put them together, just leave them as they are. Even though it doesn't feel quite right, you'll benefit in the long run if you do that.